Hello, chemistry students. Today, we're going to look at something a little bit different from balancing equations. We're going to look at actually classifying chemical reactions into one of 5 different types. So, the first slide from the slideshow, which you can access in Google Classroom, says there's 5 types of chemical reactions. So, here we go. The first type is a synthesis reaction. And in a synthesis reaction, the key thing I want you to notice in these examples here is that as you look at them, this tool will work. In each of these synthesis reactions, you start with multiple things on the reactant side and just a single product. So it's multiple things combining to make a single product. Now I'm going to show you a demonstration of a synthesis reaction, which is going to be this last one, where I'm going to take magnesium and combine it with oxygen to make magnesium oxide. All right, for this first demonstration, I've got a piece of magnesium metal, which is kind of a silvery looking piece of metal, and I'm going to react it with the oxygen that's in the air. And I'm going to do so by heating it up using this Bunsen burner. And when I do that, you'll notice that it is giving off a very bright light as it's reacting with the oxygen. Little bits of it are falling off now into this evaporating dish. In just a minute, we'll see what all we've made. If we look at what we've made in here, there's this kind of white powdery looking substance, which is magnesium oxide. The next type of chemical reaction is a decomposition reaction, which is essentially the exact opposite of a synthesis reaction, where instead of putting two things together, you're taking one thing and breaking it apart. So I've got some examples of some decomposition reactions. You'll notice you have a single reactant and multiple products. So the general form is something breaks apart into multiple things. And now I'm going to show you a demonstration of this last reaction where I'm going to take hydrogen peroxide and break it apart into water and oxygen. I've got some hydrogen peroxide. This is a 30% solution, so it is about 10 times as concentrated as what you'll find in your local drugstore. And to that, I'm going to add some dish soap just to capture the product of this decomposition reaction. And peroxide will decompose just all by itself very slowly. It's accelerated by exposure to sunlight, which is why peroxide, when you buy it at the store, is usually in a brown bottle, or in this case it's in a solid white bottle to prevent sunlight from getting in there. And then I've got this thing called a catalyst that will speed up the reaction. This is potassium iodide. When I add this to it, it will trigger the decomposition to happen much faster than normal. As you can see right here. It's giving off a tremendous amount of steam, so this reaction gives off a lot of heat. And it's produced an awful lot of the products of this reaction, which are water, largely in the form of water vapor, and oxygen gas, which is what has produced all of these bubbles. And the reaction's still going there. The third type of chemical reaction is a combustion reaction. And in a combustion reaction, that is where a hydrocarbon, which is something that contains, as the name implies, both hydrogen and carbon, combines with oxygen, and the products are carbon dioxide and water, and these reactions also give off a lot of heat. An example is that CH4, which is also known as methane, combines with oxygen to form carbon dioxide and water. I'm going to demonstrate a combustion reaction involving propane now. Got some soapy water, and it's connected to a gas line here. So I'm going to add some propane gas. So we're just blowing a bunch of bubbles full of propane, and we'll see what happens in just a minute here. All right, so I'm going to set this propane on fire. In a single replacement reaction, this is where an element that is uncombined or single replaces an element that's part of a chemical compound. And they follow the general format of the single element A plus the compound creates a new compound plus something else that's single. So some examples of this are these two reactions. You have, for instance, zinc plus hydrochloric acid makes zinc chloride plus hydrogen. Or silver nitrate plus copper makes copper nitrate and silver. You'll notice that on the reactant side, you have one element by itself, in this case zinc, and in the other case copper. And then when the reaction's done, you have hydrogens by itself or silvers by itself. So I like to think of this as, for instance, you and your significant other are going on a date together, and you decide to bring along one of your friends as a third wheel on the date. And your friend that you bring along is single. And by the end of the night, you are now the one that's single, while your former best friend and your former significant other are together. So that's single replacement, if that helps you with this analogy here. The last type of chemical reaction is a double replacement reaction. And in double replacement reactions, you have different atoms and two different compounds replace each other. So if we go back to the dating analogy from single replacement, well, double replacement reactions get really weird, where you essentially have, it's like you're going on a double date, and by the end of the night, everybody switched partners. These are a couple of examples of double replacement reactions. These two reactions don't work very well on camera. Okay, during a chemical reaction, you may see the letter S or L or G written in parentheses besides a species in a chemical reaction. And all that's telling you is what state of matter they are. So S would be solid, L is liquid, G is gas, and then there's another one which is AQ, which means dissolved in water. Or you may see an example of that is in the following reaction, where you have potassium iodide, which is aqueous, reacts with lead to nitrate, which is also aqueous, and it makes potassium nitrate plus lead to iodide, PbI2. Potassium nitrate is aqueous, lead to iodide is a solid. If we balance the equation, we would need some 2's there. So in this reaction, you have two things that you're starting with that are dissolved in water. You make something else that's dissolved in water, and another thing that's now a solid. And there's a fancy term for a solid that forms in a reaction. It's called a precipitate. For this single replacement demonstration, I'm going to take some silver nitrate, AgNO3. I'm going to add it to this test tube. And see, the silver nitrate has a clear color associated with it. And then I'm going to take a piece of copper metal, It's all shiny and copper colored. And I'm going to put it into the silver nitrate and we'll see what happens. Now, while that reaction takes place, I'm going to also demonstrate a double replacement reaction where I'm going to take some potassium iodide and put it in this test tube over here. You'll notice that it is clear in color. It's potassium iodide, Ki. And to that, I'm going to add some lead 2 nitrate, which is also clear in color. It's colorless, essentially. Now add that, and you'll see that this yellow substance forms. And that yellow substance is lead 2 iodide. And that is a solid that will slowly sink to the bottom of the container. And if we take a look at another example that I've already done and let sit for a couple of hours, you can see that the solid lead 2 iodide has sunk to the bottom of the container. That is our precipitate that we have formed right there. If we check back in on the copper in the silver nitrate, you can see that the copper is starting to become a little bit discolored as silver deposits are forming on it. And we'll check back in with that later and see how it ends up. If we check back in, we can see that little crystals of silver metal have started to form all over the outside of this copper wire as we have performed this single replacement reaction. You can actually see those little crystals of silver all over the wire. All right, the other thing to look at, now that we've seen all these examples, is how do you know a reaction's taken place? Well, some obvious signs are if a gas is produced, you get bubbles. If you make a precipitate is when a solid forms that was not originally there. You've mixed 2 liquids and a solid forms. You could have a color change where a new color appears. Now, a color change is different from a dilution. For instance, if you take red Kool-Aid and you add water to it and it turns into light pink Kool-Aid, that's not a chemical reaction. You just added a bunch of water. And then the absorption or release of heat. So those are all the indicators that a chemical reaction has happened. If those happen, it's a good sign there's a reaction.